graphs of quadratic equations. So for graphing quadratic equations, we are going to have some conditions. So here the graph of y, okay, this is a function, y, or you can have f of x too. Y is equal to ax to the 2 plus bx plus c. So a, b, and c can be replaced by numbers. So in the examples, you're going to see that. And we have that this function, the graph of this function is going to be a parabola. What is a parabola? A parabola is going to be a graph that has a U shape like this. And that parabola can open up or down. That is going to depend on the sign that you have here, replacing the letter A. For example, if A is positive, the parabola is going to open up. If A is negative, the parabola is going to open down. Something else that you have to have in mind is that you're going to have an axis of symmetry. What is the axis of symmetry? The axis of symmetry is going to divide the parabola into equal parts. So you're going to have that A is equal to B and B is equal to A. We have a formula for the axis of symmetry, and it is x is equal to negative B divided by 2A. Later on, we're going to see how to solve this. Another condition that you're going to have for the parabola is the vertex. So the vertex is going to have two parts. This part that is going to be x and this part that is going to be y. So if you realize this part is the same that the part that we have in part B, the axis of symmetry, negative b divided by 2a. So we have, when we are in the part of the vertex, we have already solved it. Just copy and put it here. So this part, okay, this part means that you're going to evaluate the axis of symmetry in the whole function. Later on, we're going to see how to do that. And finally, something that you have to do for getting the graph of a parabola, you have to find x and y intercepts. So we are going to see in exercise 1 how to do that. Now we're going to see example number 1 about graphing quadratic equations. So the first thing that we are going to analyze is that in this case you have A, in this case A is going to be 1, B is going to be equal to negative 2, and C is going to be equal to negative 3. So if you analyze, in this case, A is greater than 0, means that A is positive, so this parabola is going to open up. Okay? Now, after doing this, taking this information from the function, we are going to find our axis of symmetry. So the axis of symmetry, as you know, is going to be x equal to negative b divided by 2a. So we are going to replace this information by the information that we took from our function. So in this case, x is going to be equal to negative. B in this case is going to be negative 2 divided by 2 multiplied by a, which in this case is 1. So our axis of symmetry is going to be negative multiplied by negative. It's going to be 2, and 2 multiplied by 1 is 2. So our axis of symmetry is going to be 1. Okay? Later, we are going to find our vertex. So for finding the vertex, remember this is the axis of symmetry. Okay? Axis of symmetry. Now we are going to find our vertex. For the vertex, I gave you a formula. The formula was negative b divided by 2a, comma, and in the function you evaluate this result. So it's going to be negative b 2a and close the parentheses. So we are going to find our vertex. So for the vertex, we have the first part. Our first part is this. that we found it here. So it's going to be 1, comma. And we are going to find the second part. The second part is going to be replacing the 1, this number, inside a function. So we are going to replace the x by 1. So we are going to write our function y equal to x to the 2 minus 2x minus 3. So y is going to be 1 elevated to the 2 and replacing the x by a 1 minus 2 multiplied by 1 minus 3. Then y, order of operations, 1 to the 2 is 1, minus 2 multiplied by 1 is 2, minus 3. So y is equal to, in this case, 1 minus 2 is negative 1, minus 3 is negative 4. So y is equal to negative 4. So our vertex is going to be 1, comma, negative 4. So we have our vertex found. Then the second or the third step in this case is finding we are going to find the intercepts in x and the intercept in y. Okay, so if we find the intercept in x, intercepts. So we are going to find the intercept in x when y is equal to 0. So in that case, I'm going to write my function y is equal to x to the 2 minus 2x minus 3. So we are going to find the intercept in x. So we are going to write it like this, x to the 2 minus 2x minus 3 equal to 0. So replace the y by the 0. Then we can do this by guess and check. So I'm going to write 2 parentheses and equal them to 0. This x, we have 2 x's, 1 x here, the other one there, minus, copy it, then negative multiplied by negative is positive. Now think about 2 numbers whose multiplication is 3, negative 3, and whose subtraction is going to be negative 2. What about negative 3 and 1? Let's check this. Negative 3 multiplied by 1 is negative 3 plus 1 is negative 2. So it's okay, the factorization is okay. Then we're going to find that we're going to have here two solutions. X minus 3 is equal to 0, or x plus 1 is equal to 0. Then x is going to be equal to 3, or x is equal to negative 1. So I have 2 solutions, x equal to 3 and x equal to negative 1. Finally, we are going to find our intercepting y. Our intercepting y is going to be when you replace the x by 0. So if we have our function here, y is equal to x to the 2 minus 2x minus 3. You're going to replace the x by a 0. So x to the 2 minus 2 multiplied by 0 minus 3. Y is equal to 0 to the 2 is 0 minus 2 multiplied by 0 is 0 minus 3. So if you solve this, you're going to have that the answer is going to be negative 3. So my intercept in y is going to be negative 3. My intercepts, because in this case I have 2, is going to be 3 in x and negative 1. So right now we are going to see how to graph this in the coordinate plane. So we are going to have our quadratic function graphed. So after doing the steps, we have here a summary of what we did. We found the axis of symmetry by using the formula x equal to negative b divided by 2a. Remember, we replaced each value given in the function here, and we found this 1. The axis of symmetry is x equal to 1. Then we found the vertex. The vertex, we use this formula, and remember this part is the same you did here in the axis of symmetry. What do you do? To find this part is that you're going to replace this value in the function and you're going to evaluate it. And we got is negative 4. Okay, our vertex vertex is going to be 1, comma, -4. We are going to see how to graph this. Then we found the intercepts in x and the intercept in y. These are the intercepts in x, we have 2 intercepts, and in y we have 1 intercept. Then we have our coordinate plane where we are going to graph the information that we found. So we're going to do step by step. The axis of symmetry. The axis of symmetry is going to be a line that is going to be in 1. So x is equal to 1. So our axis of symmetry is going to be a line that is going to be like this. Okay, a dotted line like that. Then we are going to graph our vertex that comes from 1 to -4. Okay, 1, remember this is x and this is y. Okay, so 1 all the way to -4. So 1, 2, 3, 4. So our vertex is going to be right here. Then we are going to graph our intercepts, the intercept in x and the intercept in y. So in x we have 2, 3 and -1. So let's graph here. Positive 3 is going to be 1, 2, 3. Right here we have positive 3. And then we have -1, which is going to be right here. And remember, this parabola is going to open up since a is positive. Then our intercept in y is -3. Remember, this is x, and this is y. So from 0 to -3, so you're going to have here a point. 1, 2, 3. -3 is right here. Okay? So since we already know our parabola opens up, we are going to join our points. So, and remember, try to do a U shape like that, and this goes that way. So our parabola is graphed. Now we are going to see how to graph our quadratic function by using Geogebra. So our function is y equal to x to the 2 minus 2x minus 3. Okay, we are going to write x. Here we have the exponents, x to the 2 minus 2x minus 3. And here we have our function graphed. Okay, and you can appreciate the intercepts in x. Here we have the -1, here we have the 3. The intercept in y was -3. Okay, here it is. And the axis of symmetry is this line that you can see here that crosses the number 1 in x. And this is our vertex. And the parabola opens up since a, in this case, if you appreciate here the function, in this case a is equal to 1 and is positive. So the parabola is going to open up.